Now we are at the second half of chapter 3, which is on inverse Laplace transform. So assuming that you know what is Laplace transform, where Laplace of ft equals to fs. So now we are going to do the reverse. That means the inverse Laplace of fs will give you back to ft. So if you have already mastered the Laplace transform, by right you shouldn't have problem with this inverse Laplace. Okay, so the first one that we have here is inverse Laplace of fs equals to ft, and that's the same goes for all your Laplace transform and their inverses. So we know that Laplace of e to the at ft. Okay, so this is your first shifting property, gives you f of s minus a. Therefore, inverse Laplace of f s minus a equals to e to the at ft. Okay, second one, we have also Laplace of Heaviside function t minus a equals to e to the negative as over s. So the inverse Laplace of this gives you ht minus a. That is the second one. Okay, the third one, Laplace of ft minus a ht minus a. This is the second shifting property, gives you e to the negative as fs. So if you take the inverse of e to the as negative as fs, gives you ft minus a ht minus a. So the third one, Laplace of Dirac delta function is equals to e to the negative as. So if you take the inverse Laplace, you get delta t minus a, and we know that Laplace of ft Dirac delta t minus a equals to e to the negative as fa. So if you take the inverse of e to the negative as fa, they will give you ft delta t minus a. And what about the rest? The rest are also the same, just that they are easier. So we mentioned a few of these harder ones that requires more steps. Okay, so there is one trivia here. What is inverse Laplace of 1? So how do you get inverse Laplace of 1? I think in our previous video, we know that Laplace of delta t equals to 1. This is from your Dirac delta function. So that means inverse Laplace of 1 equals to, answer will be delta t, provided you know Laplace transform of delta t equals to 1. Okay, so that is why it's called a trivia here. Now we have some examples. Find the inverse Laplace transform of the followings. Okay, the first question, you are given fs, which is 4 over s squared plus 9. Okay, so the first one, let me write here. We know this is your question. We try to determine which formula to use. This maps to a over s squared plus a squared. Okay, but you have to be careful. Our a here should be 3 because this is a 9, but up here it is a 4, so you have to do a little bit of manipulations. So Laplace inverse of 4s squared plus 9 equals to, okay, so this is 4 over s squared plus 3 squared. In order for us to use this a up here with the a squared down there, I need to multiply this with 3, okay, because I need a 3 up here actually. I need like this. So I multiply 3 with 3, divide with 3. That won't change my question. So I take 3 multiply with 4 over 3. So if you can see earlier on, you can bring this 4 over 3 outside. 3 over s squared plus t squared. Okay, and we know that Laplace of sine at equals to a over s squared plus a squared. So Laplace inverse Laplace will give you back sine at. Okay, so inverse Laplace of 3 over s squared plus 3 squared. If you use this formula here, answer will be sine 3t. So this is the answer. Okay, so sometimes it's not that straightforward. You have to change the question somehow, a bit here, a bit there. I put it here because I don't have enough space later on. Okay, part B. The question is 1 over s to the 5. So we know that this maps to something over s n plus 1. Okay. Therefore, inverse Laplace of 1 over s to the 5 equals to inverse Laplace. Okay, I'll put this as 4 plus 1. If I put 4 factorial, I have to divide with another 4 factorial for me to use the formula. So this is 1 over 4 factorial outside. Inverse Laplace 4 factorial over s plus 1. If you refer to the formula, this is 1 over 24. Inverse Laplace, they will give you t to the 4. That's the answer. And part C. Fs equals to 6 over s plus 1 to the 4. So we know that this maps to f s minus a. Because you have this s minus 1 together, you cannot split it. So somehow it has to be connected with s minus a. So we know Laplace transform of 6 over s minus 1 to the 4 maps to Laplace transform of f s minus 1, because our a is 1 here. And what is Laplace transform of f s minus 1? if you refer to the formula, the first shifting property, they will give you e to the at ft. Okay. So we have f of s minus 1. You're comparing them, is 6 over s minus 1 to the 4. So in that case, what is fs? This is one thing, this is one thing. If you change it with 2s, you get 6 over s to the 4. So now we have a equals to 1. We can find our ft because we need to put it inside here later on. Ft equals to inverse Laplace of fs. Okay, what is this now? This is inverse Laplace of s3 plus 1. It happens that this is nicely written, which is t to the 3. Therefore, inverse Laplace of s over 6s minus 1 to the 4 equals to, we put it inside here, e to the 1t times ft, which is t to the 3. That is your answer. Okay, so these 3 examples are quite easy, involving inverse Laplace. We have one more example down there. That is roughly the same, maybe a little bit more challenging. Okay, inverse Laplace of 2 over s minus 2 square plus 9. So we know that this maps to inverse Laplace of f. Again, this is s minus a. Because of this, that's bound together. So a equals to 2. f s minus 2. We're comparing this with this whole thing. 2 over s minus 2 square plus 9. So in that case, what is fs? S square plus 9. Okay, this is like one thing. Okay, you can write this one also. Inverse Laplace of f s minus a equals to e to the at ft. That will be easier for you actually. So with that, we can write inverse Laplace of 2 over s minus 2 square plus 9 equals to e to the at. Sorry, I think we missed out one more step. We put this one to later on, okay? I still need the ft. With this fs, I can find my ft first because I'll need to use it later on. Okay, this is 2 over s squared plus 9. ft, you have to take the inverse Laplace. This is 2 over s squared plus 9. I need a 3 up here, divided by 3. So this can fit into the formula. 2 over 3 inverse Laplace of 3 over s squared plus 9. And the answer is 2 over 3. 3 over s squared plus 3 squared sine 3t. Okay, so lastly, put into the question inverse Laplace of 2 over s minus 2 squared plus 9 equals to e to the at ft. E to the at ft. So that is the answer for this question. And one more here. This inverse Laplace maps to, again the same thing, inverse Laplace of s minus a equals to e to the at ft. But this is not yet in the form of s minus something. We have to change it a little bit. How to bring in the s minus? I factorize this one first. Sorry, this is 5/2. Or too many layers. Okay, I'll take this one out first. So this is 3/8 times 1/s plus 5/2 to the power of 3. I can put it as s minus 5/2. Okay. So now this thing can be mapped to inverse Laplace of f s minus a. That means f of s minus a equals to this thing here. F s minus a equals to 3/8 okay, because our a now is minus 5/2. So if that is the case, f of this thing equals to 1 over that thing. Fs equals to 3/8 1/s to the 3. And with that, we need the ft first. Later on, you need to use it here. Ft equals to 3/8. Maybe I'll write the inverse Laplace first. Okay, 3/8 inverse Laplace of 1/s to the 3. So I will change this a little bit in order to be able to use the formula. 2 plus 1, I need a 2 factorial, so I divide with a 2 factorial. Okay, this one I'll bring outside together. 3/16 inverse Laplace of 2 factorial over s2 plus 1. So this is 3/16 t to the 2. So lastly, inverse Laplace of 3/2s plus 5 to the power of 3 equals to e to the at, e to the at ft. Okay, so this is the inverse Laplace transform, just directly by using the table of Laplace transform. The next part, we have another 2 parts. One is using the partial fraction, and another one is to use the convolution theorem.